Tadi part 1 tu I accidentally end my recording, so 6 minit je lah part 1 tadi, tapi tak apalah. Okay, we move to the part 2 of the video for today's asynchronous lecture, and we go back to example 5. Example 5, if you remember, kita dah discuss, but we just find the eigenvalues. Saya tak cari lagi eigenvector, and I leave it to you to find the eigenvector for all the questions here, kan? Saya tak pastilah you all cari ke tak. Okay, so for here, I'm gonna show you. Okay, sekarang ni kita akan carilah eigenvector untuk kita faham apa maksud linearly independent. Okay, so let's say we have the vector here. The given vector in the question is vector A, negative 2, negative 1, negative 1, 2. Okay, so from what we have discussed sebelum ni, okay, kita dah dapat jawapan dah. We have discussed before where the lambda value is equals to 1 and 3. Right, so this lambda value 1 and 3, tapi kita tak cari dia punya eigenvector during our synchronous lecture. So now saya nak cari dia punya eigenvector where we have A minus lambda I, kan? So we consider first for lambda equals to 1. So 2 tolak 1, we're gonna have 1, negative 1, and then negative 1 here, and 2 tolak 1, we're gonna have 1. Alright, so we have here x1 and x2 to get the eigenvector, and we let it equals to 0, 0. Hence from here, we're gonna have x1 minus x2 equals to 0, negative x1 tambah x2 equals to 0. So dari sini kita dapat the equation, we deduce the equation x1 must equals to x2. x1 must equals to x2. So 1 eigenvector for lambda equals to 1 is, kita ambil lah yang paling senang, x1 sama dengan 1. If we let x1 equals to 1, then x2 as well equals to 1. So there you are. We're gonna have lambda equals to 1. Our eigenvector is 1, 1. Okay, let's consider lambda is equals to 3. So the vector A minus lambda I will be 2 tolak 3 is negative 1, right? Negative 1, and negative 1 here, negative 1, 2 tolak 3 balik is negative 1. Okay, then x1, x2, 0, 0. So what we have negative x1 minus with x2 equals to 0. Second equation pun akan dapat yang sama. So here we have negative x1 is equals to x2. So what shall we let as your x1 and x2? So let's say we let x1 equals to 1, then what will be your x2? x2 will be 1, negative 1 lah. Right. So to apa ni, untuk tahu jawapan you betul ke tak, then you may proof lah macam saya buat. Ax times equals to lambda x. Yang ni memang confirm betul, so I skip that step because what I want to show you next is kita tu lah. Because yang tu you dah tahu kan. So here lambda equals to negative 1. Add the eigenvector for lambda equals to negative 1. Dia punya eigenvector is 1, negative 1. Alright. What I want to highlight here is untuk you faham apa maksud linearly independent. Okay, what does it mean by linearly independent? Okay, apa maksud dengan linearly independent is that these two vectors, okay, is not a multiplicity of satu lagi. Faham tak? Katakanlah macam satu-satu ni kan, dia bukan kata kita boleh faktorkan, dia ada faktor sepunya. Macam mana nak cerita? Katakanlah kalau it is linearly dependent, kita ada matrix kita X ni 1, 1. Satu lagi matrix kita kata 3, 3. This is what we call as linearly dependent. Ni katakanlah X1, this is X2. Because X2 sama dengan 3 kali X1. Nampak? Dia depends on X1. Tapi macam yang kita dapat sekarang ni, dia tak ada hubung kait. Kita tak boleh nak relate between the first eigenvector with the second eigenvector. So, that's why we call it linearly independent. Kalau contoh yang macam ni tadi, then yes, it is linearly dependent. X2 ni, we can say it's 3 times X1. 3 times X1. Okay, tu cara untuk kita buktikan it is linearly dependent yang ni. Okay, sebab kita boleh hubung kaitkan the two matrices together where the eigenvectors that the two eigenvectors that we have right now, we are unable to show such a way like this, meaning that it is not dependent but it is independent. Okay, the issue is sekarang macam mana kita nak tunjukkan dia independent. Dia ada cara dia ya untuk you buktikan dia independent. Okay, macam mana nak buktikan dia adalah independent adalah, okay, listen carefully. Saya tak ada tulis dalam lecture notes ni, so make sure you understand. Okay, untuk kita buktikan, what we do is we combine the two eigenvectors together. Kita combine the two eigenvectors together and kita katalah dia adalah big X kat sini. Okay, where the first eigenvector we put it in the first row, first column. The second eigenvector kita letak in the second column. Okay, the second eigenvector in the second column. So, what we'll do next, kita cari dia punya determinant. So, you find its determinant of these two matrices, of this matrix where it is actually a combination of the two eigenvectors. So, we cross multiply, kita akan dapat 1 darab negatif 1 is negatif 1, tolak 1. So, we get negative 2. So, what does this show is that negative 2 is not equals to 0. So, if it is not equals to 0, maknanya shown the two eigenvectors are independent. You have to write this, okay? You have to write this to show that you cannot like show that the two eigenvectors are equals to 0. Then you just say does not equals to 0. You kena cerita lah it does not equals to 0, maksudnya terbuktilah the two eigenvectors are independent, because the syarat for the two eigenvectors to be independent to each other is that its determinant bila kita combinekan the two eigenvectors is not equals to 0. Okay, hopefully everyone understand this. I'm going to go back to our notes chapter 1 part 2 now. Okay, apa yang saya explain just now has dia punya cara it has been written here. Okay, so maknanya determinant of X is not 0 dan the n vectors are linearly independent. Kalau dia sama dengan kosong dan the n vectors are linearly dependent. Boleh faham Oh, it has been written here. Okay, next kita faham. Okay, the first learning outcome for today is for you to faham apa maksud eigenvectors are linearly independent. You may try for the rest of the examples that yang kita dah try so far, from example 2, example 3, example 4. Okay, show that all the eigenvectors that we get are linearly independent. Okay, how to? Macam saya buat tadi lah, buktikan determinant dia tak sama dengan kosong. You may do that. Alright. So, in example 6, okay, what I'm going to do now is to show, we want to find the eigenvalues and eigenvectors. Ada kelainan di sini, where for this one, our matrix size is no more 2 times 2, but 3 times 3. So that's why it is written here for n equals to 3. The order is order of 3, or dimension dia is 3 times 3. Okay, basically step dia sama je, cumanya dia punya dia punya, bukan kata step dia panjang sikit lah, because we have the size of matrix now 3 times 3. Tapi the order of the step tu sama je sebenarnya. Okay, where we introduce lambda, kita faktorkan. Okay, but to faktorkan here is a little bit challenging, because now we expect to have 3 lambda. Okay, because we have now 3 times 3 matrix. Okay, let us proceed for example 6 here. Okay, so sekarang ni saya nak tunjuk cara how we are going to find the eigenvalues and eigenvectors for 3 times 3 matrix. Kita try example 6A dulu ya. So, step dia masih lagi sama, where we determine the determinant of A minus I lambda equals to 0. Jadinya, the matrix A I lambda ni, A lambda I pun boleh, I lambda pun boleh. Okay, the matrix here will be, dia punya matrix ni akan jadi, kita nak cari dia punya tu kan. Sebenarnya each of the diagonal value ni kita tolak dengan lambda lah. Kan? Kita tolak dengan lambda, because kita tahu identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. And each one ni dia akan ganti dengan lambda lah, sebab kita darab dengan lambda kat depan. Alright, so here we're going to have 1 minus lambda, negative 1, 0. And then negative 1, 2 minus lambda, negative 1. And then we have 0, negative 1, and 1 minus lambda. Okay, so dari sini we are to determine the determinant of this, and we let it is equals to 0. So again, yang ni menggunakan your skills that you have gained from your engineering maths 1. How to determine the determinant for 3 times 3 matrix. So saya tak akan explain balik. Saya just tunjuk cara je ni. Tak mas if macam kabur-kabur or ingat-ingat lupa with the step, get back to your engineering maths 1, tengok balik lah all the notes. Okay, so first is I'm choosing the first row. So I multiply with 1 minus lambda. So kita tutup first row, first column. So we're gonna have 2 minus lambda darab dengan 1 tolak lambda. Dia akan menjadi sedikit je lah complicated sikit kat sini. And then minus, dia kan polarity dia minus with negative 1 kat sini. Be careful, negative 1. And this time kita cross the second row, the second column, first row. So what we have is negative 1, 1 minus lambda, tolak ni, negative 1 darab dengan kosong, so it's gonna be kosong. So tak perlulah tolak kosong, saya buat je macam ni. And then finally tambah si kosong kat sini kan, so tambah kosong je lah, equals to 0. You don't have to proceed with the cross multiply tadi macam tadi, sebab dah sah kita akan multiply dengan kosong kan. So what we have over here, okay, this is a big bracket over here. No, it's not a big bracket. So yang ni the first 1 minus lambda, yang ni pula untuk negative 1, yang ni pula dengan untuk kosong ni kan. So kosong kita tak tulis lah, because of course definitely dia akan jadi kosong. So in here we're gonna have 1 minus lambda darab dengan 2 tolak lambda darab dengan 1 minus lambda. And then kat sini negatif 1 darab dengan negatif 1 darab dengan negatif 1 kat sini. So negatif darab negatif positif, positif darab dengan negatif, kita akan dapat tolak lah. Kita akan dapat tolak 1 sama dengan kosong. Tolak 1 sama dengan tolak 1 sama kosong pula. Tolak tu tertinggal tu. Tolak 1 tolak lambda. Okey, kejap. Okey, tolak 1 tolak lambda sama dengan kosong. So as you can see here, there is a common factor where you can factor it out, which are again, saya rasa saya ada made a mistake here. Cuba you all tengok, betul tak ni cara saya kira untuk dapatkan determinant ni. Alright, so because I think there is a mistake here, saya dah tertinggal yang ni kan, 1 minus lambda, kita tutup first row, first column. So it be 2 minus lambda, betul. Darab dengan 1 tolak lambda, betul. That's it. Salah tu. Sepatutnya dia kena tolak dengan negatif 1 darab negatif 1 ni. So sepatutnya dia kena tolak 1 tu. So saya dah tersilap kat situ. So by right dia adalah 1 tolak lambda darab dengan 2 tolak lambda darab dengan 1 tolak lambda tolak 1. Barulah lengkap untuk the first cofactor. Untuk the first term ni yang kita nak darab dengan 1 minus lambda ni. And then minus with, yang ni betul lah, negatif 1. Negatif 1 ni dia akan jadi positif 1. Okey, dia akan jadi positif 1. Lepas tu darab dengan negatif 1. Okey, darab dengan negatif 1. So dia akan jadi tolak 1 tolak lambda je. Because yang ni kan, tadi kita darab dengan negatif 1 ni. So negatif 1 darab dengan 1 tolak lambda. Lepas tu dia tolak dengan kosong pula ni. Because kosong tolak 1 is kosong. And then tambah kosong tak payah tulis lah. So this is what we have. Okay, and as you can see we have 2 terms kat sini. This is the first term and this is the second term. And both ada 1 tolak lambda. So you may factor out 1 tolak lambda out. So what we have over here, kita dah fakturkan 1 tolak lambda out. Then we're going to have 2 minus lambda darab dengan 1 tolak lambda tolak 1. Okay, and then yang ni because kita dah fakturkan keluar, so dia jadi tolak 1 je lah. Equals to 0. Right, so here 1 minus lambda ni biarkan dulu dan kita cuba selesaikan yang kat dalam ni. So when we expand this, we're going to have 2 minus 3 lambda plus with lambda square minus 2 equals to 0. So yang ni dengan yang ni you may cancel. So what we have is 1 minus lambda dan juga lambda square minus 3 lambda. Do we need to expand this? No need. Because dia dah cantik tu, dia dah berada dalam bentuk factored form. So what we have is, kita ada, yang ni you boleh factorkan lagi. We have 1 minus lambda ni biar. Lambda square, we can factor out lambda. So we have lambda minus 3 equals to 0. So daripada sini, kita akan dapat 3 value. We have lambda sama dengan apa? Satu yang ni, 1 minus lambda equals to 0. We have lambda equals to 1. Satu lagi kita ada lambda sama dengan 0. Satu lagi kita ada lambda sama dengan 3. Nampak? So, altogether we have 3 lambda. Lambda equals to 1, 3 and 0. Remember macam mana cara untuk kita determine whether we have gotten the correct eigenvalues or not? Macam mana? We find the summation of lambda kan. So, summation of lambda ni kita akan dapat 1 tambah 3 tambah 0 is equals to 4. So, dia sama tak dengan the trace of A? So, this matrix, the trace of A, what is the trace of A? 1 tambah 2 tambah 1. So, it's going to be equals to 4, right? 1 tambah 2 tambah 1, 4. Yes. We have gotten the correct answer here where we have 4 and here is 4. So, maknanya betul lah tu. Our, our eigenvalues, we have got the correct eigenvalues. Okay. So, sekarang ni you dah nampak dah cara macam mana nak cari the eigenvalues. Sama je step dia, cumanya it has to go extra lah because sekarang ni kita ada 3 lambda. So, the step tu is a bit tough when it comes to factoring untuk dapatkan all the 3 factors tu. Okay. So, what we're going to do next is to determine the eigenvectors. Okay, to determine the eigenvectors. So, I think we are going to proceed to find the eigenvectors of this example 6a in the next video.